In the Wake-Word detection, this is our last video. How to record your own audio. To build a truly custom Wake-Word model, we need to our own dataset. A simple way to use the open speech recording app, which is runs most browser with microphone access. The app shows word prompts and user record each utterance directly through the clean interface. Each recording is saved and uploaded to the cloud storage bucket like Google Cloud. You can also customize the list of words editing JavaScript array for the main and filler prompts. The audio files are stored in a OGG format, which is efficient to space, especially for the silence clips. For the training, we converted them to the 16 kilohertz. And mono waves, its invalid clips like very short and silence one should be removed. For the example, deleting files under 5 GB, tool skipping the manage to easier. Batch converts all OGG into the waves. Next, we will see the data augmentations for audio training. To make our training dataset storage, we use data augmentation, which creates a new variations from existing audio clips. This is especially useful for the datasets. It's small, since helps to the model generalize better and improves accuracy. Typically, the transformation include the adjusting volumes levels, mixing in the background noises, it's and slightly shifting the starts and end clips. Knowing time shifting, and it's the training scripts automatically applies this augmentation by default. We can fine tune and them to command lines arguments such as the background volumes to set how to load the noises its background frequencies, to control how the often non is added, the time shift ms to define the offset for the shifting. It's important not to overuse augmentation. Too much distractions can actually hurt accuracy. And all, see the custom architecture. In the default Wake-Word model provide the TensorFlow Lite. It's designed to extremely lightweight. It's only about 18 kilobytes in the size and requires around 4 lakhs operations per inference. This makes for it ideal for the low power microcontrollers through to thus the trade-off some accuracy for the speed and efficiency. If you need to recognize more categories to improve performance, you can design a custom architecture. This is the done by editing and models Python file, where you define your own functions. For the example, create my custom model. Then you can update the create model functions to include your model names. Custom models can use additional layers, drop out for the regularization or more complex structure, and you can select them during a training with the model architecture augments. Let's go to the warping app. In our real world speech recognition, by building a reliable system in multi-layered challenges, several components play the important role. The model architecture and the type of audio pre-processing applied, the use of data augmentations, the quality of training data, and finally how the efficient of the model is deployed on the hardware. Each designs choose involves of trade-off. A smaller model may run faster and microcontrol but lose accuracy, while the larger model may perform better but require more memory and power. The goal is to strike the right balance between this constraint and the real world usability. In this section, we will explore how the inference works with different data types. With this, we completed the Wake-Word detection project. You now understand how the audio is captured, converted into future, passed through a neural network, and post-produced to reliable recognize spoken commands. In this next part of this course, we will continue our TinyML journey with the Magic 1 project. This time, instead of audio, we will work with motion data from sensors to recognize the hand gestures. It's a new domain but build the same principles of the model training and deployment, giving you a broader perspective how TinyML can be applied in real world scenarios. And thanks for watching.